Thank you, and good afternoon, everybody. It's a pleasure to be here. Not often you get to present in Adelaide, let alone present a project that's in the backyard here in South Australia. So I appreciate the opportunity. As mentioned, Gold Hydrogen is all about hydrogen. It's about hydrogen gas. And recently, last year in October, November, we drilled 2 wells. We also identified helium in that process, so I'll talk about all of that as we go. The disclaimer, you've seen a few of those today, I'm sure, and this is probably similar. I'll just run you through a few things about the company and the project, where we sit. So just in summary, the company was formed in 2020, and it was formed, as I said, to search for natural hydrogen, hydrogen that's produced by Mother Nature deep in the subsurface. And the green, in the map you can see there, the green shaded tenement is our granted tenement, which we're currently doing work on the Yorke Peninsula. The salmon colour and the grey colour are application tenements. We have to go through the native title process before we can move them to be granted tenure. But we're kicking off with that on the area just north of our Kangaroo Island granted tenure. What we did before listing IPO was in January last year. Prior to that, we had an independent expert certification of a prospective resource for us, and that came in at 1.3 billion kilograms of hydrogen, the main best estimate. And as a result of drilling our wells last year and encountering helium, we also had a prospective resource report done on that, which came in at around 40 odd BCF. Again, best estimate. And to put it in some context, 40 BCF is about 7 years of global production or use currently of helium. So it's a sizable resource in its own right. Our project area is significant. We've got a massive footprint. Our Yorke Peninsula footprint's over 7,000 square kilometres, and the application blocks 67 and a bit thousand square kilometres, so nearly 75,000 square kilometres. So we've got a project of significant scale. We were, if you look at our progress from IPO January last year to drilling in October, November, that's pretty rapid in terms of going through the whole approvals process. And I've got to say that working with the South Australian Department of Energy and Mining was a dream, and really thankful to them working with us the way they have to enable us to get that work program done last year. The samples that we got during our drilling operation last year was up to 86% in some samples of hydrogen, and up to 17.5% air corrected on the helium. We've got relationships with some significant companies, CSIRO working with us. They're doing a whole lot of testing, not just here in Australia, but in France, in labs over there that they have relationships with in universities over there. Schlumberger have done a whole heap of work for us getting off the ground, including studies and helping us determine the sort of wells that we need to drill, how to drill them. Total Seismic have done a lot of reprocessing work for us on the seismic that was existing. We're also planning to do a significant seismic program this year. I'll tell you more about that later. Excalibur did a flyover gravimetric survey for us, which provided a huge amount of data for our geos to pore over and try and identify better areas to target for leads and prospects. And Savannah was our drilling contractor last year. They're an experienced oil and gas drilling contractor, and they mobilised a suitably sized rig for what we wanted, and they performed really well for us. And we've got relationships with other companies now on site doing well testing for us. They're very experienced gas well testers. The important thing about what we're trying to do, I think, is contribute to the decarbonising of our energy sources, effectively globally, locally and globally. And natural hydrogen is an opportunity for us to come up with a low-cost energy compared to other hydrogens that are being manufactured by man. This is manufactured by Mother Nature. Also, the helium that we've identified is a highly valuable commodity. It's a commodity in short supply globally, and if we can identify and develop the helium that we think we can, that'll be a valuable asset for the company. So a bit of a snapshot capital structure. Currently about 200 million market cap. We've got cash on hand about 20 million. That's enough for us to do our next 12, 18 months work program, which includes drilling, seismic, further well testing. It's nice to be part of a company that's actually performed so well since IPO, and it's very pleasing. So generally, industry-wise, the investment in hydrogen globally is growing, and it's significant, it's massive. The billions of dollars being poured into downstream hydrogen uses, handling, and now there's a lot of activity similar to ours globally in terms of drilling for natural hydrogen. The opportunity to develop hydrogen as an energy source is gaining momentum, and there's massive investment driven by governments because they're looking to decarbonise the planet, but there's a whole lot of industry investment in it as well that's looking to capitalise, I guess, on the opportunity for hydrogen becoming part of our energy sector or energy landscape going forward. Things that are happening, I've mentioned decarbonising, the ESG sort of concept and trying to green the planet is a key driver. Technologies in terms of handling and use of hydrogen in fuel cell electric vehicles for transport is one aspect of hydrogen use. Again, fuel cells, but also turbines. There's a number of major gas turbine companies globally that have now developed gas turbines that will run on a combination of hydrogen and natural gas, even up to 100% hydrogen. So there's a lot of potential downstream application already being developed technology-wise. In Australia, Toyota and Hyundai have fuel cell electric vehicles. I don't think there's many, there might only be a few, but in Victoria, the Toyota facility has fuel cell electric vehicle demonstration, and I believe the Brisbane City Council has a Hyundai fuel cell electric vehicle that gets its hydrogen from one of the gas plants out on the east side of Brisbane. So helium is different. Helium is a very stable gas. It doesn't interact with anything. It doesn't combust. It's used in predominantly healthcare and also the space industry. They're the two big users. Electronics also uses it. Helium is part of the matrix or cooling matrix for these applications. So it being an inert gas, it's stable and it can be used in these situations or in these industries as a cooling agent, basically. Also, because it's inert, it's used as a shield on some specialist welding applications. You might be familiar with the colour coding of hydrogen. It's an industry adopted standard that I think began in Europe some time ago now, but it's been adopted globally, and there were way more colours than I mentioned on this slide for different carbon sort of combinations or use of carbon in the formation or manufacture or production of hydrogen. Natural hydrogen is often referred to as gold or white hydrogen, and hence the name of the company. Grey is hydrogen that's been developed using an energy source of natural gas. Black, brown, oil and coal are the energy sources for the production of hydrogen that way. Blue is using natural gas, maybe coal, but predominantly natural gas, where the carbon that is generated from the process to generate hydrogen, any CO2 that's generated is then sequestered into the ground, so not released to the atmosphere. And green hydrogen, which is something that's more commonly in the media, is hydrogen that's produced using renewable energies as the energy source for the electrolysis process that generates the hydrogen. So solar panels or wind farms provide the energy that for the electrolysis process, which generates hydrogen from water, basically. So natural hydrogen has got a low, arguably zero carbon footprint. The others have some degree of carbon footprint. And in terms of cost of production, there is a small village in the country of Mali in West Africa that's been producing hydrogen for about a decade or more, and that hydrogen goes through fuel cell technology to produce electricity for that village. And papers that have been published on that indicate that it's a private company that does all that. A bit hard to get a lot of detail, but the papers that have been published indicate $1 per kilogram. The work that we've done indicates that that's probably a realistic number, perhaps even less, depending on the scale of development that we're able to do. And that puts the cost of hydrogen and power generation comparable with the cost of current electricity generation. Others are more expensive. Helium projects, this is a bit of a snapshot of some projects in the US. There are others globally, but the concentration or purity of helium in the gas stream on projects generally is fairly low, perhaps comparable to other gases, but a purity of helium of above 8% is pretty uncommon. One of our peer group companies, Pulsar, just recently published results from one of their exploration wells in the US of about 13.5% helium, and that's not air corrected. Ours is air corrected to remove traces of oxygen that were identified in the sample which aren't truly there. So we've got it with the purity of hydrogen from that sample. It's very encouraging, because if we are able to actually prove that up and produce, we've got a valuable world-class opportunity here. So that's a bit about the industry. The company itself, from a geological perspective, and I'm not a geologist, but what we're looking for here is really something related to traditional conventional gas. And when we drill down into the Earth's crust, into the subsurface, what we're trying to find is a reservoir containing hydrogen. Now, the hydrogen is formed deep down through radiolysis or electrolysis, and hydrogen, being a very small molecule and a light gas, will migrate towards the surface, and we're looking for structures that trap it. Back in 1930, a company drilled Ramsay Oil Bore 1. We drilled Ramsay 1 about 150 odd metres away from that well, but back in 1930, Ramsay Oil Bore 1 drilled looking for oil on the York Peninsula. They found something that burnt. The chief geologist from South Australia took samples and identified it was hydrogen. So we know there's hydrogen there. We've drilled adjacent to that, so we're confident from what we're seeing that there's seals and traps there, and we're basically ticking the boxes of what we need to identify. I'm going to have to rush through this. The prospective resource reports are based on SPE's PRMS, so they're done in accordance with known and respected guidelines. Helium can't be produced by man. It's produced naturally through radiation degradation. We've got plenty of work coming up, and I think I'll just have to leave it there. If you want to ask questions, please come and see me at the booth.